Hi, with me is the Singapore Cambridge GCE O-Level Additional Mathematics Syllabus 4049 2023 paper number 2. Currently in Singapore, the GCE O-Level examinations are underway, and next week marks the final week of examinations. This Monday was the Additional Mathematics paper 2, and it was regarded by many students to be one of the harder additional mathematics papers that they have done in the past 10 years in their 10-year series books. This particular question stumped many students the most. It is a question on trigonometry identities, and we will look at this question today. Use the identity for tangent 2a to show that tangent 15 degrees is 2 minus square root 3. So in this case, we have to refer to our formula sheet, and it just happens to be here. Tangent 2a is right over here. So it says that 2 tangent a is equivalent to 1 minus tangent squared a. We will apply this formula to help us answer the trick question over here. So when we look at this question, what we have to recall is our special angles. We have 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. I realize that 30 degrees is 2 times 15 degrees, so in this case I will use 30 degrees for my 2a. And then I can get started on the question. So what I will start off here is tangent 30, and with reference to the formula sheet, it is 2 tangent 15 over 1 minus tangent squared 15. And if I recall for my special angles, tangent 30 is 1 over square root of 3. You can always type into your calculator to verify if that is right. It is 1 over square root of 3. Great. So it will be 2 tangent 15 degrees 1 minus tangent squared 15 degrees. What I can do is that I can cross multiply. This goes here, and that goes there. So on the left hand side, I have 1 minus tangent squared 15 degrees, and it is equivalent to 2 square root 3 tangent 50 degrees. And what I want to do here is that I want to construct a quadratic equation in terms of tangent 15. So my quadratic equation will look like this. And since I have a surd as one of the coefficients, there is no possible way that I can factorize this. So what I want to do is that I want to use the quadratic formula. I have tangent 15 degrees minus 2 square root 3 plus minus square root of 2 square root 3 squared minus 4 1 negative 1 over 2 times of 1. Now at this stage, if you type into your calculator, you can use your mode 33 for a Casio calculator or whatever brand of calculator you're using. If you go into the quadratic equation function, so it should be press mode, there you see an EQN, go to ax squared plus bx plus c. We type in the coefficients, and then we have 1 positive and 1 negative root. So in this case, this is the stage where I reject the negative answer because tangent 15 degrees is more than 0. Since 15 degrees is an acute angle, and we know that the sine, the cosine, the tangent of any angle, of any acute angle is positive. It's positive for sine, cosine, and tangent. This is sine positive, this is tangent positive, and this is cosine positive. So ultimately, what we are left with, let me just check. That's right. So we have to reject the negative root. So in the end, what we are left with is tangent 15, negative 2 square root 3 plus square root of, I can evaluate what is in the square root. Use your calculator. So in your square root, it should be 16. And 16 is a perfect square, so we can simplify that. Negative 2 square root 3, square root 16 gives you 4 over 2. And I want to rearrange it to this form over here. So it should be 4 minus 2 square root 3 over 2. We will split it into two separate fractions. And in the end, tangent 15 degrees is 2 minus square root 3. And I've already shown that tangent 15 is 2 minus square root 3. Great. Now move on to part B, where I'm required to prove that tangent 15 degrees minus tangent 105 degrees is 4. Okay. Also seems like a pretty scary question. And this is where I reckon most candidates would just give up and just move on to the next question. But this is how they're supposed to solve it. They're supposed to use their answer from part A for tangent 15 degrees. And for the tangent 105 degrees, I want to think of two special angles that can add up together and give me 105 degrees. In this case, I have 60 degrees and 45 degrees. 2 minus square root 3. I can use the addition formula for tangent. Scroll over to the formula sheet. The addition formula for tangent is right over here. So it is this. And then you have to pay attention to the negative sign, because negatives can change whatever sign there is. So put a bracket next to it. And then this is where I can also use the sine, cosine, tangent on my special angles. I know that tangent of 60 is square root 3, tangent 45 is 1. Then I have 1 minus the tangent 60 square root 3, tangent 45 is 1. So 2 minus square root 3. I will rearrange the numerator to give me 1 plus square root 3. At the bottom, I will also have 1 minus square root 3. Then what I can do, I can rationalize it by putting a conjugate set next to it. And then in the numerator, I'll have 1 plus square root 3 squared. And then I have the conjugate sets, so it's 1 squared minus square root 3 bracket squared. So I have 1 minus 3. 2 minus square root 3. 1 plus square root 3 bracket squared. I can use my special algebraic identities to expand it. So I have 1 plus 2 square root 3 plus 3 over negative 2. And then I'll have 4 plus 2 square root 3 on negative 2. I have 2 minus square root 3, negative 2 minus square root 3. That is where I can multiply the negative sign in to whatever's in the bracket. So I have 2 minus square root 3 plus 2 plus square root 3. Negative square root 3 and square root 3 cancel each other out. I'll be left with 2 plus 2, which is eventually 4. And I have proven that tangent 115 degrees minus tangent 105 degrees is 4. And this is the trick question for the 2023 paper 2.